Okay, so today, bringing on this GTP38. This is a pretty rusty, rough one, but we're going to go over. This will be a long form video going over build practices, assembly practices, things to look for, things to check with these. This one's already had, so the reason it's in here because it had a cracked unison ring. It has a new unison ring that's going to go in. This has been cleaned up, as well as because of the corrosion, even the new unison ring, you have to open them up a little bit. So you want to pull these all the way apart to properly clean them. Front plug comes out, side plug comes out. You want to take everything apart, except for you don't got to do your water passages. There should not be any oil, debris, mess inside there. So first things first that we want to do is we have to put this cap on because there's a front top plate that goes in here. If you put the top plate on, you can't put this guy back in there. So hang on, I'll let you do that. Clean. Grab the oil, grab the O-ring. Clean your O-ring up. So we're gonna kind of go over why all turbocharger builds too take so long. Nothing that I do here is high speed as far as repairs go. So there's no skipped steps. So that it takes the length of time that it takes because there is nothing that's missed. And I know that that can suck, especially if you have something that's broken and you're in a hurry. But I mean, there are other places for that have pre-made components that, as turbochargers go, they're not even necessarily from all the places measured correctly and properly, but that's what warranties are for. My goal is to never have to even consider even needing or using the warranty stuff. So that's a big deal to me. I know that having the warrant, everything has the warranty, but having like a warranty, like using it, no one wants to have to use it. So kind of made that my goal. So instead of having like the warranty there as like a safety factor for you, my plan is for you just to never even need it in the first place. So one of the ways that makes that happen, makes it happen really, really good, is take my time and measure absolutely everything. By going through this process of measuring everything, you can't really skip any steps because you have to measure everything. So it makes it take extraordinarily long. But the pro is that you get a turbocharger that is built to OEM standards bare minimum. So what does that mean? So I was looking into kind of how an OEM would actually mass produce high volumes of turbochargers while things stay accurate. And on top of the amount of money they have in testing that goes into these things, they have some pretty wicked measuring tools that they use, like touchless. So they're using like lasers to measure, and every so often, like these parts are being milled and machined in climate-controlled rooms, and every so many of them will come apart or come out, get pulled, and checked for accuracy. And the way that they are checking for accuracy is they're checking for accuracy using like laser scales. You can look these up. I looked them up on eBay just to see what they cost. I was curious. And they're not cheap. And it's not just a laser micrometer, it's a bunch of other stuff that goes along with laser micrometer. So that's kind of how you get into the measuring like these super, and these are climate controlled stuff and all this like crazy stuff. So how do how do you get to that point? Or how do you build something that is to, say, like that quality without all those fancy tools? We'll use manual tools. The manual tools are slow. And so it just takes up and adds a lot of time to the assembly process. But ever since doing this, I really started doing this about almost 3 years now ago. Literally have not had a single failure due to assembly and or manufacturing defects, because I can catch them. You can measure a defect and you can visually see a defect, and because nothing is being done at extremely high rates of speed, get to take the time that it takes to see if there is an issue. And that makes such a difference. And I just, like, to me, as a customer also of things, like, that has to feel nice. Like, I know it feels good in my own vehicles when I get in them and I don't have to worry about it breaking. Like, I don't know about you, but that is a really sucky feeling. And I've been there, like, when I'm testing and prototyping new stuff, I am worried of it failing. And that's a sucky feeling to have. So it's like nice to be able to offer something that, although it takes a lot, like quite some time to build, right? It's slow. This is not a high speed process. So we're used to this. This ring here, for the most part, all your snap rings are punched or rolled out of some like a sheet steel. So what that does is that causes one side of your ring to be more round than the other. So on anything that is applying a load to the ring and the groove, you want to put the sharp side of the ring facing out towards the pressure, like towards the direction of pressure of the groove. So in this case, this plug is going to want to be pushed out from the oil pressure. So we're going to put the sharp side of the groove facing out. You saw that as I put this together, we made sure to put some assembly oil both on the slider and itself. So these things don't pop in all the way all on their own. What you're going to want to do, okay, we're still green. Just get yourself a little hammer and a punch. Make sure you push this guy all the way in. Was actually the other direction from Garrett originally, and now we are facing the direction I prefer to put these rings in at. I'm going to be right back and get a flashlight. Alright, so visually, my ring's all the way in there, we're seated all the way down, and that's good. Kind of sucks about putting this in is you can no longer see where your groove is, but it's not a huge deal because it kind of only goes one way as far as the orientation and the sliding goes of this dude. Don't worry about putting the piston in yet. I did that earlier, and all I did was have to fight the whole time. So the next thing we're going to do is we need to put our front plate on. But before we do that, we need to measure our through bore on the CHRA. Now, we know that this turbocharger has lived a really long time, so why are we doing this now if we're going to go back in? Well, one, if we have to adjust the bearing size because the bearing is worn out, I will know. And two, there are not a lot of public books on modern turbocharger design and theory that are free. What is free is measuring what currently has been used and has lasted this long. That's what I'm going to do here. So I'm going to make sure. Oops. Okay. That's at 0, so we can open this up. Check. Now I would like to have a dial bore indicator for these things. The problem is per small change in the size of these, and you need 2 per turbocharger, one for the ID of the journal bearing and one for the ID of the center cartridge. They're about $300 each, and I repair more than one style of turbocharger. So I'd very quickly end up in a scenario where I would have more money in inside bore gauges than my truck's worth. I got 17,870. Here, write this down. Yeah, there's a chart here that all this is going to go onto afterwards, but for sake of speed, I just run down right here. Your through bores are usually done with a reamer. They should be, ideally, as long as there's no wear, which is what we're checking for, there should not be any difference front to back. So that's good there. So I need to go, so that checks out. That's standard for the GT3788. It's standard at least with what I measure. Let's grab our assembly. So the next thing that we're going to start working on is putting the back plate together. So these turbochargers kind of assemble like a little bit funky. They have no snap rings that hold anything together. I have these piston covers and stuff. Let's grab this. So 14. Backside is going to be, shoot, this here. Oh, I need my collars off of my balanced assembly. We have an upper turn, but a lower no turn. So I always keep note when I take, and I write, so if you ever get a DIY kit from me, I write on the DIY kit how to align the collar system. They don't always rotate with one another because the machining of the collars is not always perfectly flat. So when the collars are really, really flat, everything will rotate with the compressor wheel. When you have like a high-low scenario somewhere on one of the collars, you do end up where one collar rotates and one doesn't. Not the end of the world. This turbocharger lived for this long with this, technically speaking, defect in the collar system. I'll say they have really nice machining from Garrett on their compressors. The hardness is super nice. The only thing we got to check here, because the 360-degree bearing, is we need to check collar thickness and denote all this before we go put it all together. So, be surprised if we find some variation of high-low. 6142. 40. 40. 40. 40. Yeah. This one's looking nice. I think 614 all the way around. Maybe I'm mistaken on this one. 40. Let's check our thrust bearing. So, I am a big advocate of using original parts when applicable. Yes, this one's good. So these, I'm pretty sure these thrust bearings in these GT chargers are a compressed powder metal, powdered steel. What's interesting is on the front face, the taper is put in with the manufacturing process, but on the back, they put the taper in with some very, very light tooling marks. Don't know why. Maybe for expediency's sake, that's how it works. What you want to do when you're checking your thrust bearing is you want to check every individual pad. They won't. OEMs have the best consistency pad to pad. Then all your aftermarket stuff. Like here's an aftermarket bearing, and there's nothing wrong with the aftermarket bearing, but this will have a greater variation pad to pad. 4364. 4364. 4365. 4. Oh, okay, there we go. Okay. 4. This one's the same. 3. 4. Round. Next thing we need to go check is yeah. So there's nothing. Like I said, there's nothing quite like your original OEM parts. So when you can, I always recommend that you reuse them as long as they're not damaged. One 710. So want to, for sake of taking a small break, we can take a look at what that looks like. There, so 6.140 minus 4.364 minus 171. It's a pretty tight factory clearance. So the last one I just did was a 0.077. This one's a 0.066. Divided by 2 gives you 0.033 per side. So for oil to flow through in the metric system, I'm pretty sure 0.001 is the smallest space we can run. I think it's 0.001. Or it's 0.01. I think it is 0.001. 0.001, I think it's a micron. I apologize if I'm wrong on that. The big thing that you want to consider is when dealing with the stock turbochargers, though, is the rate of flow through. So the tighter the clearance gets, the better the load zone support is, but the hotter the bearing system is going to run. Now, all that being said, these are all the original parts of this turbocharger. They look great. So there's no heat discoloration going on here. There's no weird wear going on. So everything looks fantastic. So when we took this thing apart, nothing moved on the bottom. So that sure we're clean. You know, paper towel's not the cleanest thing in the world, but it's been working for a really, really long time. Now, this goes here. This has no spin, so pre-clock them just a little bit. I will be right back. I'm going to clean the bearing. All right, bearing has to clean. Just for like kind of fun's sake, so just cleaned it with brake clean, so it's cold as can be. And let's see if we had to change in size. So we're down approximately 0.003. 004. Yeah. So by cooling it, we reduce the size of the bearing by 0.004 millimeter, and the opposite happens as it warms up. So That's why we're checking all these clearances to make sure that when this thing grows, when it's in startup, that everything is good. Related ironing. On top, you want to keep your oil away from your threaded holes. Those threaded holes, we're going to use the red Loctite as well as thread sealant. The main reason for buying the rebuild kit, in all actuality, is that I need the gaskets out of it. The sealer backing plate on. I am, like I said, a very, very, very firm believer in OEM components. They were not out to, I don't know in too many cases, they do exist, but where the OEM was out to like actually target you and try and pull one over on you. Stuff like that happens, but not as commonplace. I don't know what those were. Maybe the Ford version or something. No. This is the square cut gas or O-ring for doing the back of this. What I probably should do is, now that I'm doing more and more of these things, I should probably just measure one of these out and order them on McMaster Car, and then I don't got to get full kits just to get some gaskets. So I use an assembly grease on these. Kind of helps hold them in place while we go get our set up our back plate. I'm an advocate of original hardware, like the Chinese. I mean, it's true. Okay, the Chinese are not out to give you, as far as these rebuild kits go, the nicest hardware in the world, right? They're out to make money. Nothing wrong with that. Just be aware when you're using stuff that's not original. The likelihood of a lot of DIY stuff actually being out there to help you and not make $1 off you is, from my own personal experience, really low. I think that used to be a thing, and I just feel like the way things are today in this super high speed environment, nature, whatever you want to call it, has just kind of ruined a lot of what made kind of the old stuff awesome. There's a lot of stuff that I've bought and purchased that was sold to me as something, and it certainly was not anything near what I had purchased. And kind of after enough of that happened, I kind of changed how I just do things. So we are now working on the nose. We're going to grab our front piston ring seal. This is important. We're going to put it into our plate and check our front piston ring gap. Make sure it's not too tight. Again, these are all, in this case, components that have survived this long, and this is more of a learning experience as well as adjusting if needed. Because these are all good. So on these particular ones, I like to take your upper thrust collar. Oop, come on in. Here it goes. Push them up pretty far. Make sure you're even. And so the Garrett stuff, what you'll have to buy, I don't know if they have these local or not. my standard set of feeler gauges is just standard feeler gauges. If I can have them. So like standard size gauges. To do a lot of the Garrett stuff and KKK stuff, you have to go to like this set here with the thin front. Garrett likes to run bigger gaps. But we're going to see what we got here. The front looks nice. So the front looks like it's going to be an 05 again. Just did one of these, and I want to say it was a 05. So this one is a 04. So we are 0.001 tighter on this one. Awesome. The other kind of interesting thing too is with the Garrett being an aluminum backplate, is that it's going to have probably different growth rates than stuff with steel backplates as far as this ring cap goes. But our ring looks great. So what'll happen on the rings, these are cast iron, is they'll develop a really hard edge to them over time. But I like the OEM stuff when possible because the spring cast iron that it's made from is definitely going to be more heat tolerant to not losing that ring tension as it gets warm or as it has to cycle through things. That looks great. Pop our ring on. That's great. If you want to, you can use WD-40 on this. You don't have to. It is supposed to be a relatively dry system. You always get some form of oiling that's going to get through here. That's just how it goes. But this is a dry system. So your arrow on your backplate on the GT3788 faces up. And I want to say on TP and GTP 38, so this is a GT3788 face up, and then TP and GTP 38 faces down. I'm pretty sure. I have to go check in the back, but I'm pretty sure they face down on those chargers. I should say the direction I've always kind of done it is they face the oil feed. So your piston ring gap, you always want to be facing the top, so face it towards your arrow. Boop. Face it in there, and we are looking pretty good to go. So we got one on the top, we got our square cut grow seal in there, thrust bearings facing the right direction. You could probably put it upside down, I guess, on these ones. Don't recommend that being something you do. So we did have a front rotation on this one, and this is a counterclockwise system, so we're going to rotate you out. And what I like to do is take my flashlight, so I can see through the holes, and set this down here. So everything looks great. That's in. Now this is your last chance. As soon as you cover the sucker up, if you got to do anything to it, or forget to put anything in here, you take it all back apart. Okay, there we go. There we go. Cool. We are down. So next thing from here is putting on our bolts. So how I like to do these, because these are on the inside of the oiling thing, is we got some Permatex high temperature thread sealant. I'm going to put a little bit of that on this inside here. Not do nothing wild. Go. And then a little bit of high temp thread locker. Just a smidge. If you use too much, what will happen is as you install this, it ends up just squishing out everywhere. That's a massive waste of time. So kind of feel them go snug and then back them off a hair. I'm going to repeat this process, so I will probably speed up the video right here. That's our last one. So now these are down, crisscross, hand tighten these. Put this away. And as soon as I get back, I'm going to torque them. Now, torque spec on these, because they're going into the steel center cartridge, I do like 300 to 350 inch-pounds. That's pretty high for an M8 bolt. So standard M8 bolts, so it's going to be like 18, 20, 21, 22 foot-pounds. That's 250, I think, or 280. I think it's 250 inch-pounds. We're going to go higher. So when we do these, we're only going to do like 250 because we'll strip them out easy as can be. But these inside ones, they run pretty tight. We don't want these ever coming apart. I prefer that the turbocharger explodes before we ever have to take these bolts out. Alright, so snug them all up in a crisscross. Got loose. 1, 2, 3, 4. Just checking, going back over. Okay. Alright, now that those are all good, we can work on our rotor assembly. And that's it. This is a really weird way when you assemble turbochargers because you do everything kind of in a funky direction. So now, because this thing is very awkward to hold, what I like to do is we'll just take a block and it's going to sit upside down like so. So there's no heat shield on these guys. Oh, real quick, before we get too far, we do need to go ahead and check our rear ring gap. And like I showed in another short video, the rear ring gaps on these are kind of insane. Right, so this is the one from this turbocharger. Okay, so this one has a really good groove in it. But I want to clean it up real quick and just show, at least look at how big the gap is in this thing. Because it'll, usually in these Garretts, it's kind of absurd. One moment. Also, I'll show you how the rear rings wear out. Then we're going to lube it up and shove our finger in it to get oil all the way up to the nose of it. Sounds kind of bad. Did I put you away? No. Where are you? So we stay relatively organized to some small, tiny degree. To check your ring gap, you want to take your ring and put it all the way in. Okay. So for this back ring, because it's big, we can use a regular feeler gauge. If the other one's not regular, this is just my normal one that I use. So I can already see like daylight through this thing. Let me find. This is a 13 again. Yeah. So 13 fits. Like this is like they're in like a big gap in these. And I don't know if it's because of temperature or because there's no heat shield, which is always kind of strange to me, but it could be because there's no heat shield. It helps get, so the idea of the gap in the ring is it's supposed to let exhaust gas by into the case, and by letting the exhaust gas by into the case, that keeps the oil from exiting the case into the exhaust stream. That's the idea behind it. I don't think it works in practice super great. Check the fit. I usually always end up putting split gaps in And you still end up kind of with a big gap with the split gap ring, but I feel like it helps at least keep like bigger pieces of carbon from entering the turbocharger. And it's kind of the big reason why I put the splits in, because you still have a fair amount of room, but it does make me feel better about them. So split back, front's the 005. Front's fine, like by all intents and purposes, front's perfectly fine. So turn these things kind of upside down. You can set them on their top like so. Alright, let's drop oil down this sucker. That's how I like to do these. You can put quite a bit in these things. And just take your pinky here and lube them up real nice and good. Land here, just make sure it's not like overly coated in oil. Nothing super crazy. And you'll be fine. What you don't want to do is like fill up the rear wing land with oil, with like a heavy oil. If anything, use like WD-40, but like a very kind of light anti-rust-ish will be fine. It'll flash off as soon as it kind of starts up. Alright, so that's good. Let's put you here, you here. Let's measure this shaft. We need to measure these bearings. Clean up some stuff. Let's be right back. One thing I try and always do when it comes to measuring these things are kind of dirty, bearings is don't clean them with like a solvent too soon before you measure, because the temperature change is going to really throw off everything. So if everything you've been measuring is all at your standard kind of temperature outside, or is around you, then you want to try and maintain that while doing your measuring, because bearings will really change a lot inside if you hit it with the brake clean and then try and measure them out. And these, yeah, there's like some crap on here and crud that we'll have to take off here in a moment. Kind of, yeah, neat part with a lot of these Garrett chargers is, for the diesel stuff, is there is no snap rings that hold anything in. So everything is like a full floating system. You just want to watch that if you're taking them apart outside, or somewhere where they can end up on the ground. You want to make sure you don't drop all your important biddies on the ground. So let's get our through bore. Check here. The other kind of interesting thing with the Garrett journal bearing is the Garrett journal bearing has only 4 feed holes to center, wherein everybody else, so they're the same, has 1, 2, 3, 4, 5, 6. So here's a S300 has 6. 1, 2, 3, 4, 5, 6. Here's the 351 has 6. Do more holes? That would be like an interesting kind of question to kind of look into, I guess, though. I can, if the area of the hole is of the hole's total is less than the area of the volume shaft clearance wise, then do you need more holes or less holes? You kind of almost see more holes as maybe having more holes that are rotating in the low pressure zone, the non-load zone of the bearing, that would allow oil to then flow from that zone into the center shaft. But at the same time, these things rotate pretty freaking fast. So 17763. 3. One thing too is that the bearings aren't always exactly perfect. A lot of times you can go in here and put your small bearing in the rear, big bearing in the front. 3. So the last GT37 we did had two different sizes by barely anything. So it's a 765 to a 767. This one's coming out as 763s for all of them. Check our ID. So 17763. Yeah, okay, got to write it down. Yep. 11530. Here tight. Oh. Yeah, 11530. So we got 11530 on the ID and 17763 on the OD. And we checked our shaft. So the main purpose of this exercise in the case of putting together a turbocharger that's been living is to learn what allows them to live. And then to take that information when we get to the next turbocharger, like say it's a brand new one, or say this thing was totaled and we got to put new bearings in it, I need to make sure that the bearings that go in it are correct, because I could probably grab this brand new bearing here. And let's see what we got. This is 17776, right? So this is not going to be the same reinstalled clearance as what's been in there. So the original bearing is a 17763, and if I had to put a new bearing in it, this new bearing is 17776. That's quite the increase in size when we're talking about clearances that are already pretty tiny. And if you didn't have measuring tools and you did this, and you just so happened to say you had a through bore that instead of 17870, what the through bore was 17860 or 850, and then you also came across this bearing set put together, and you put the whole thing together and then wonder why it failed. And the same thing happens from other manufacturers, is they're also, as much as I don't like to pick on nobody, they aren't measuring to this extent. Because it takes time. Like, as you can see right now, this is taking a considerable amount of time just to do all this stuff. So they might measure a few of them, but it's different when you're an OEM and they're making tons of these things, but the rigorous testing done by, not shouldn't say testing, quality control done by an OEM is so much higher than anything overseas. And I like the overseas people. I deal with them all the time. But what I can tell you, they don't care if what they sold you works or not. Right? They got paid. But you care if it works or not. That's where measuring comes in. If there was a place doing standard stuff that every 3,000 bearings they pulled them and they were the exact same, like an OEM does, you probably wouldn't have those, like, a lot of issues. That's where, like, I see it a lot now that I'm measuring. There's a lot of people that have been told they have oversped their turbocharger, that they did not overspeed their turbocharger. They had the wrong size journal bearings in it. I've measured a lot of places stuff. Now, right, and to at least give myself some crap too, I did not used to do this, and I certainly paid for it a lot. when I did not do this setup all myself. And ever since I did start doing all of this setup, all these issues went away. Because I started learning about how all this stuff works, understanding how journal bearing systems work, understand how thrust systems work, understand how the oil moves through a turbocharger. None of it is intuitive at all. None of it works how we want it to work. It's a very interesting and dynamic situation. And that even gets into like thrust bearings, like how flat thrust bearings should be. So, like these thrust bearings here, I really like these ones. But when they make a thrust, this is a forged part, so it comes out like they're just chopping these and then face them, put your grooves in, or they actually put these grooves in here with a milling machine. What happens is these probably sit in a thing, a track, and they actually get rolled like through a press, so they're forged into being what they are. That's the fast way to do it. But the thing is that tooling doesn't stay perfect forever, and what happens with that tooling is 11495, is because that tooling wears, the part that it manufactures is slowly becomes slightly different. Like this bearing here, I don't know where it went. Actually, I don't know where it went. It says HD on it, or yeah, it says HD on it, like one of these. These things are like one, they're way too thin, and two, I've had them where like these lower two pads are like 0.0, like 0.02 undersized compared to the rest of the pads. So if you think about how the bearing system is actually loaded, you end up with some, on top of that, some like really crazy freaking dynamics. Yep. Boil up our shaft hard. That's what's kind of neat about like why, once you start seeing why places do certain things. Like when I look at the, like I used to be like, why is the Garrett turbine so big? Why is it a 13 blade? And the more that I've done this and studied it, the more I understand why they've done the things that they do. The whole reason the blades count so high on these, for example, is because I forgot to put our piston ring seal on. See, I've been talking and almost messed up. The whole reason blade count's high is it reduces the channel size between each blade. And what that does is that when the vanes are in the more closed position, remember, no heavy oils on your ring. I just made this extra hard on myself. When you have high velocities and low volumes, such as vanes closed at low engine speeds, you get a lot of what would be essentially kind of described as like flow reversal. Like the flow, it's really easy for the flow to want to turn around on itself and go crazy turbulent. And it's not really a big deal performance wise to the turbocharger that this is occurring down here. The issue is in the durability of the metal itself gets fatigued at much faster rates when that occurs, and then failures occur. And when you're an OEM making millions of these things, that is a really, really big deal. Problem, and we don't want that to happen. Yeah, these look great. OEM stuff is so nice. You're gonna put these on here. Put on a little bit more goo. Oop. Spacer. Leather bearing. A little bit of lube on outside. Kind of. What's kind of wild too about like these things is how overbuilt Garrett did with the diesel turbochargers compared to their um like other line of turbochargers, like their more performance oriented spark ignition stuff. And I know they've done great. Like I know like there's a lot of the G series stuff out. I think the G series stuff's awesome. I just think like the earlier, maybe like the GTs and stuff seem to be like a bit on the smaller side. Then you get into like TDO, the TDOs and stuff like that are all kind of like rookie numbers, and you get into these things, and you're just like, Jesus, they're nice. So we want to do here. We're actually going to swivel over to our vise. Here we go. Oh, I like to clamp these by their big piston. This is where I messed up because I put the piston in earlier. It just wanted to fall out the whole time. There we go. Sit there. So remember, piston ring seals always face up towards the opening. No different with the turbine side. This is going to face up towards our opening. If you catch any tiny little specks on anything, make sure you get those. It's always weird putting these things all the way in. There you go. So like a little twist and a little push, and they'll just pop right in there. If this was a billet wheel, I recommend using a white lithium grease. It'll usually say if you got it from me, it'll already be on there when you're going to tighten it. With this being a factor wheel, the machining is super nice, and I've never had problems with them coming apart. So just put them on there, feel it pop over the threads, and then thread them all the way down. So from want to find our marks. I always kind of try and rotate in the direction of standard rotation until it's actually torqued all the way up. On these particulars, it's a 14 mil in the face. You want a 14 deep, and it's 22 on the back. Left-handed threads. So we're going to tighten until all of our marks line up. And it's not so much the marks for compressor to turbine, because they're really hard to see on these big assemblies. It'll be the marks that are on the compressor to nut here. Yeah, it looks good. Oh, and that's that. So I pre-torque all of my stuff before I balance it. So there's no torque wrench part when it comes to putting these parts together. The torque spec I go to is on these, I want to say it's like 160 inch-pounds. It's higher, 150, 160. If it's going to damage itself, it's going to damage itself. The amount of load that's under these things when they're actually making some steam is pretty high. So don't be afraid to test your luck unless you don't want to test your luck that day. So say it's a Friday and you need it done for that day, probably not. Probably don't want to do that. But yeah, so this is, let me take it out of the vise, I guess. So this is good. The next thing that we've got to do is get the turbine housing out. The next thing I've got to do is get the turbine housing out and clean it. So that's still on the to-do list. You'll be nice and tight. So your in and out play, well, we know what it is. It was 0.033, I think, since we measured everything out. But like physically, shouldn't be able to feel anything. Like you can't feel 0.033 of a millimeter. It's been nice and freely. Everything's all pre-lubricated. It is not going, if you use a good assembly lube, it's not going to just leave. And even with the standard, if you use like a motor oil to assemble this thing, it'll all stay put. It's pretty tough without new inflow to drive out the old floods in there. You'd have to spin these pretty excessive amount to end up there. So next part is I need to go pressure wash, kind of clean up that turbine housing. It looks like someone melted a candle in it. It's not pretty. Bore brush, actually I could probably show you that right now. On the vanes, because the vanes always kind of want to get stuck on the pins, what you want to do from there is go ahead and get yourself some 1/4 inch bore brushes. I get mine from McMaster Carr, 120 grit. There we go. Let me go get those. I think the vanes are right down here anyways. Yep. So if you get them at McMaster Carr and just put in like bore brush, they'll show up. It'll let you choose what size you want. And to clean all these up, because you can't really clean the pins up with a, like, they don't have, like, I can't find one. And I'd love a battery terminal brush that was small for cleaning up those pins, but they don't make one. So what's actually easier is I just get this little, like a 1/4 to 5/16 120 grit firm bristle brush, and you just turn on drill and run in and out of here a few times, and it fits great. So the new unison ring, like I said, because it's rusty, I had to use like a 60 grit disc, clean up the inside of this thing to make it slightly bigger. But now with it slightly bigger, so before, when we were pretty well stuck, now we can sit on here and it moves nice and free. And I will show you when we get the turbine housing on there. We're going to grab the piston with a magnet and pull the piston with the magnet, and it's going to run all the vanes together. That's how freely this thing has to move for it to be good for your customer or for it to be good for yourself. So I'm going to be back in a little bit. I got to go try and get the goo out of this turbine housing, and yeah, hopefully that's a success. Okay. You're back after had a little lunch and then did this. So this took like an hour-ish, 2 hours. So let's get to cleaning. Oh, like I was showing you at the end there, we're going to use our little pour brush. You got to make sure that all these are nice and smooth. Oh, yes, can. Okay, so the actuator sits about over here. He's only got one way. And how I like to put them in. But do not anti-seize any of these. Way too hot for anti-seize to do anything. Slowly line all these up. Sometimes you need a little help. Go. 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 There we go. There we go. There we go. There we go. So nice and smooth. This should be a nice smooth actuation here. Max power, no power. Max power, no power. Max power, no power. So, but I have this off one spot, so we're gonna just put it in the middle-ish. Pick it up. There we go. Sits over yonder. What I like to do is kind of want to set this up where I can see everything. I'm just going to push it over this way a little bit. I'm going to put a paint mark here. This tells me where my pin's at for locating, and then a paint mark right here tells me where my mark is to line this up. I'm going to do the same marks on my collar assembly here. Oh, okay. So before we put this on here, I actually need to put the piston in here, because if we don't, then you can't put it in once it's in here. So this is good to go. I'm going to set this down, and then we're going to bring this guy over and put the piston in it, and then we'll do all this stuff. So one, get the clamp. Actually, I usually stick this on the center cartridge. Let's do our piston real fast. I want to turn this upside down. See if I can't do this and face it towards you guys. Do it. Okay. Let me clean my hands real fast. Got a good rest going on right now. Okay, so when doing, oh, you know what I freaking screwed up? Is this is all vertical. Oh, all right. Well, that's gonna kind of suck, ain't it? Maybe I can rotate it and at least post it up that way. So putting piston in. Want to grab our piston. Make sure we're clean. So on your piston, the dot faces up. That tells you where your gear drive's at. So dot always faces up. Clean your teeth out a little bit. Make sure you ain't got nothing going on there. Make sure there's nothing in the inside of this thing. These O-rings do not come in kits. I don't even know actually where to get them without taking them off and measuring them and ordering them from McMaster-Carr. So don't screw them. But pretty sure my understanding of like these kind of O-rings is these aren't they're not like a no leak O-ring. These are more like how automatic transmissions are, where there is leak by. They just limit the amount of leak by that's occurring. That way the piston cycles like it's supposed to. So what I like to do here is take a little bit of WD-40. Don't go crazy with this. This does not have anti-foaming agents in it. So you don't want to get all crazy with anything here. So a WD-40 where this is going to be going up into, because you can't stick a finger up in there. And then we're going to glue the main piston bore and glue this guy up pretty good. So I put this on everything. Don't get too wild again. I'm pretty sure, I don't know what kind, I don't think there's really too many anti-foaming additives in here. So especially if you're doing any kind of HUI system and stuff, you want to be really, really careful. Lube everything up real nice. There we go. So what I like to do is just there. Make sure my teeth are about where I want them to be. Ow. That's nice. Alright, so I should be, yeah, okay, so right here, if I travel this direction, I'm going to grab my teeth, so take this, face it down, making sure we're staying oily and gooey. Okay, so we're in. Should slide in. There it is. So I like to have a big magnet because I want to make sure I'm on that first tooth. And then once this is sliding in here pretty freely, you should be able to pull this with a magnet pretty easily. What we're going to want to do is flip it over and take a look at the cam ring that the sensor rides on. Let me turn this over. Okay, so yeah, all the way out where we start, it's going to be start the cam ring, and then it should bottom out with this pin, yeah, with this tooth just about showing in this bore, and that is middle, or that is like correct. We're not too far in on any of these spots. The dead center, you should see where it likes to hang out. Oh shoot! I just flipped it off of here, so I'm going to go ahead and double check that I did this right. Because once you put this all together, it does not come back apart very easily. On my neck. So yeah, so no grab, no grab, no grab, grab. So that is that. I don't recommend putting, and I'll show you why. I don't recommend putting the plug in here until we're all the way at the very end of assembly on this. Now we can grab our housing. Get rid of some of this stuff. So there we go. There right now. You stay put. Once the center cartridge is in here, it'll stand on its own, but until then, kind of support it. And I like to support it where I can see both the spots here. Nice and free. I'm going to line that up there. Need our big clamp. Where did I put that? So you can flip this clamp so it's all the way over the center cartridge, and that makes this a heck of a lot easier. Now, and get down here as we set it in. There's that one. So I'm pretty sure we are good rock and roll. So my marks line up there. My vein is in there. Pull this out. Should have, well, I guess not. That had enough weight to stand up on its own. That'll work. A little bit crooked. So all of our pins look right. We should be able to take a. That's why it wants to fall. It'd help, I guess, if I put it all the way on this thing. So with the deadbolt hammer, very carefully. We can tap this down. So now that we're going, go ahead and anti-seize our clamp. That's all good. I do apologize for forgetting that should have been recording this horizontal, not vertical. Really wish there was a better way to solve that. It's just how it goes, I guess. Social media platforms and everything's always different from one another. Quarter drive is nowhere to be found. 716. How I like to do these is we're going to tap it as we're tightening it. Like to make sure that there's no contact going on here. So be careful while you're doing this to not whack your compressor. I'm pretty sure I've done it at least once. Also, don't hit out here on the edges unless you want to break it. I even still worry I might break it hitting it that far in, but okay. That's pretty snug as a bug. I don't think it's going nowhere, so we should be good there. So, now for the fun part. Once you get to this stage, hope for the best. We're going to grab our piston, and we'll have moving vanes. This is like the most satisfying part, is getting right here. So, vanes move nice and free. Compressor is nice and free. We got all our specs on the top. We're going to write those down on our sheet here in a little bit. Always spin your parts the direction they're designed to spin. The bearing systems are essentially mechanical pumps all on their own when it comes to a hydrodynamic wedge system. And you, by spinning them backwards, you kind of you'll pump the oil out of them instead of pumping it into them. So there you go. Next phase is compressor cover. Next part's compressor cover. Put the sensors back in it. Clean it up like our anti-seize and garbage a little bit and put some torque stripe on it. That way we look professional to some degree and call it a day. Also, these O-rings, I think, kind of settle in over time. This isn't a clockable component, so if you want to just take Loctite 518, you could put a thin film of it around here, and that'll seal this up real nice. I see it all times they have RTV, and it's just such kind of a messy system. The 518 looks really nice and professional. So thank you. Have a good one.